In this lesson, I'm going to teach you how to write the equation of a median, right bisector, and altitude of a triangle. Let me start by explaining to you what a median, right bisector, and altitude are. I won't go through the steps of how to find them until we actually do a couple of examples. So let's start with the median of a triangle. The median of a triangle is the line segment that joins a vertex of the triangle to the midpoint of the opposite side. We could find the median from any of the three vertices on the triangle. A right bisector is a line that passes through the midpoint of a line segment and intersects it at a 90-degree angle. An altitude of a triangle is a line segment from a vertex of a triangle that goes to the opposite side and forms a 90-degree angle with that opposite side. Notice that all three of these are line segments. So when we're writing the equation of any of the three of them, we're going to be writing the equation in the form y equals mx plus b. Y equals mx plus b is an equation that describes the relationship between the x and y coordinates of any point on a line segment. It describes the relationship in terms of m, the slope of the line, which we can calculate by doing the slope formula, change in y over change in x, which we could write as y2 minus y1 over x2 minus x1, and b, the y-intercept of the line. Another formula that we'll have to remember before we can complete this lesson is the midpoint formula. Notice when finding the median of a triangle or the right bisector of a line, it involves the midpoint. And to find the midpoint of a line segment, we find the average of the x-coordinates of the endpoint by adding them and dividing by 2. And then we find the average of the y-coordinates of the endpoints by adding them and dividing by 2. With all of that in mind, let's try our first example. Example 1 gives us triangle ABC, so we know the coordinates of all the vertices of the triangle. And we need to, in part A, determine the equation for the median from vertex C. Based on the definition of a median, I know that the median from vertex C will go from point C to the midpoint of the opposite side. So it'll go from C to the midpoint of AB. To find the equation of the median in the form y equals mx plus b, I will need to know the slope of the line and the y-intercept of the line. So let's think about how could we find the slope of the median. To find the slope of any line, you need to know 2 points on the line. Well, I know the median starts at C, and I have the coordinates of vertex C, and I know it goes to the midpoint of AB. So I'll need to calculate the coordinates of the midpoint of AB. To find the midpoint of AB, I'm going to have to average the x-coordinates of the endpoints. So to find the average of -7 and 3, I would add them and then divide by 2. And I'll also have to find the average of the y-coordinates of the endpoints. So the average of 2 and 4 I can calculate by adding 2 and 4 and then dividing by 2. So my midpoint, the x-coordinate of the midpoint will be -7 plus 3, which is -4, divided by 2. So that would give me -2. And the y-coordinate of the midpoint, 2 plus 4 is 6, divided by 2 is 3. So my midpoint is the point -2, 3. Let me label that on the triangle and make sure it looks good. -2, 3. That appears to be the midpoint. So there's my midpoint of AB. So at this point, I could draw the median. That'll help me visualize it. It's going to go from C to the midpoint of the opposite side. So that's what the median looks like. I'm going to determine the equation of that median in the form y equals mx plus b. Now that I have the coordinates of the midpoint, I now have 2 points on my line. I have point C and the midpoint of AB. Those 2 points are both on the median, so I can now calculate the slope of the median by calculating the change in y over change in x. So I'll use the formula y2 minus y1 over x2 minus x1. I'll choose point C to be my second point. It doesn't have to be, it could be my first point, but I'll choose it to be my second. And I'll do y2 minus y1, so -4 minus 3, divided by x2 minus x1, 1 minus -2. This calculation will give me -7 over 3. That's the slope of my median. Remember to write the equation of the median. I'm going to be writing it in the form y equals mx plus b. I now have my m, but I don't know the value of b. To calculate the value of b, I'll sub in -7 over 3 for m, and any point xy that is on my line. I have 2 points that are on the line. I can choose either C or the midpoint of AB to be my xy. I'll choose point C. So let me solve for the b value, which is the y-intercept. Into y equals mx plus b, I can sub in the point 1, -4 as my xy. So -4 equals, and m I know is -7/3. X is 1. The only value I don't know is b. And then we just have to rearrange this and solve for b. So I'm going to want to isolate b. So I'm going to take this -7/3 times 1, that's just -7/3, and move it to the left. It's going to be added to -4, and I'm going to want a common denominator. So I'm going to rewrite -4 as -12/3, right? -12 divided by 3 is -4. It's just rewriting it in an equivalent form that has the same denominator as 7/3 so that I can collect them together. -12/3 plus 7/3 is -5/3. So my b value is -5/3. With all of this, I can write my final answer, the equation of the median. So the equation of the median is y equals -7/3x minus 5/3. Now that line, y equals -7/3x minus 5/3, is a continuous line that would go forever, but the median of this triangle falls on that line and is contained within the triangle. Let's now do a right bisector question. So part B asks us to find an equation for the right bisector of AB. If you remember, a right bisector is a line that is going to intersect line AB at its midpoint and is going to intersect it at a 90-degree angle. In the previous question, we calculated the midpoint of AB to be the point -2, 3. We already have that. So I know an xy point on my right bisector. To find the slope of the right bisector, we're going to have to do it a little bit differently. Since we only know a single point on our right bisector, we're going to have to use the fact that it's perpendicular to AB to be able to calculate its slope. So let me start by figuring out what is the slope of AB. So let's calculate the slope of AB. To calculate the slope of AB, I'll have to find change in y over change in x. So I'll find the difference in the y coordinates, 4 minus 2, divided by the difference in the x coordinates, 3 minus -7. And that gives me 2/10, which I could reduce. 2 goes into both 2 and 10. It goes into 2 once. It goes into 10 5 times. The slope of line AB is 1/5. And you can see to get from point B to the midpoint of the line, you rise 1 and run 5. So that looks like the correct slope of line segment AB. Now that I know the slope of line AB, I can find the slope of the right bisector by using the principle that tells me that lines that are perpendicular to each other have slopes that are negative reciprocals. To calculate a negative reciprocal slope, we multiply it by -1, which effectively changes its sign, and then we find the reciprocal of it, which means flip it. So instead of positive 1/5, it changes to negative 5/1. And -5 divided by 1 is just -5. So the slope of my right bisector is -5. So if I wanted to, I could accurately draw the right bisector now by, from the midpoint of AB, I could use the slope -5/1. That means down 5, 1, 2, 3, 4, 5, over 1, and plot a point. Now that I see 2 points on the line, I can draw a line through those 2 points, and that would be my right bisector. So that's the right bisector of line segment AB. Let me just put a little right angle symbol here to show you that it forms a 90-degree angle with line segment AB. So that's what it looks like, but what's its equation? We know the slope, we know m is -5, we don't yet know b, the y-intercept. I can solve for the y-intercept by into the equation y equals mx plus b, subbing my slope of -5 in for m, and plugging in any point that is on my right bisector in for x and y. The one point I know for sure that is on my right bisector is the midpoint of AB, the point -2, 3. So I'll plug 3 in for y. The slope of my right bisector is -5, and the x-coordinate of the midpoint was -2. If I solve this for b, -5 times -2 is 10. Subtract the 10 to the other side. 3 minus 10 is b. Therefore, b is -7. Now that I have all of that information, I can write the equation of the right bisector. The equation will be y equals -5x minus 7. Part C asks us to find the equation of the altitude from vertex C. Based on the definition of an altitude, I know that the altitude is going to go from C to some point on the opposite side so that it makes a 90-degree angle with the opposite side. So it's not necessarily going to go to the midpoint. It's going to go to whatever point makes it form a 90-degree angle with the opposite side. So we'll have to do some calculating to figure out in what direction the altitude is actually going to go. Since I know it's going to make a 90-degree angle with the opposite side, I know it's going to have a slope that is perpendicular to the opposite side. And if you remember, we've already calculated the slope of AB. The slope of AB, when we did the change in y over the change in x, we got 2 over 10, which is 1 over 5. That would mean that the slope of the altitude is the negative reciprocal of that. That means flip it and change the sign. So instead of positive 1 over 5, it becomes negative 5 over 1. So knowing that slope, I could do an accurate sketch of the altitude. A slope of negative 5 over 1 means down 5, right 1, but that'll give me a point outside the triangle. So I'll do the opposite, up 5, 1, 2, 3, 4, 5, left 1. So I now know the direction of this altitude. I can connect those points and go all the way to the opposite side. And there's my altitude. To write the equation of that altitude in the form y equals mx plus b, I know m, it's negative 5, but I'll have to solve for b, the y-intercept. And I can solve for that by subbing into y equals mx plus b, the slope of negative 5 for m, and any xy point that is on the altitude. And the only point that I know is on the altitude is point C. So I'll use 1 for x and negative 4 for y. So negative 4 equals negative 5 times 1 plus b. Negative 4 equals negative 5 plus b. Add the 5 to the other side. And I figure out that b is 1. So I can write the equation of the line that the altitude falls on. Y equals negative 5x plus 1. Let's do another example. I'll go through them more quickly this time, but we're going to do another median right bisector and altitude of this triangle, triangle DEF. So the first thing we're going to find is the median from vertex E. If I want the median from E, I know based on the definition of median, it's going to go from E to whatever the midpoint of the opposite side is. So I'll have to start by calculating what is the midpoint of the opposite side. So the midpoint of DF can be calculated by finding the average of the x coordinates of the endpoints. And I can average negative 1 and 5 by adding them and dividing by 2. And I'll also find the average of the y coordinates of the endpoints. So I'll find the average of 5 and 2 by adding them and dividing by 2. The x coordinate of the midpoint, negative 1 plus 5 is 4, divided by 2 is 2. And the y coordinate, 5 plus 2 is 7 over 2. So 7 over 2. If you wanted to write that as a decimal, it would be 2, 3.5. So that would be this point right here. That's the midpoint of DF. So I can now draw the median. It's the line that's going to go from E to the midpoint of the opposite side. To write the equation of that line in the form y equals mx plus b, I need to know the slope of the line and the y-intercept of the line. I can find the slope of the line by using the formula y2 minus y1 over x2 minus x1. So I'll find the difference in the y-coordinates. I'll do 3.5 minus negative 1 over the difference in the x-coordinates, 2 minus negative 2. So that gives me 4.5 over 4. And if I were to write that with integer values and get rid of the decimals, I can multiply top and bottom of that by 2, and that would give me 9 over 8. So my m value, my slope, is 9 over 8. And I could have got that same answer by, instead of using 3.5, I could have used the fraction 7 over 2. Let me show you what that would look like. So I would do 7 over 2 minus negative 1. But I would want a common denominator, so I would write negative 1 as negative 2 over 2. That's equivalent to negative 1. Over the change in x, which would be 2 minus negative 2. So in the numerator, I've got two fractions being subtracted that have a common denominator. So I could just subtract their numerator, 7 minus negative 2. That's 9. Keep the denominator, so 9 over 2. Over 2 minus negative 2 is 4. I could think of that as 4 over 1 if that helps. When dividing fractions, you keep the fraction in the numerator and multiply it by the reciprocal of the denominator. That gives me 9 times 1 is 9 over 2 times 4 is 8. So that's just another way of getting the same answer that we had. Now that we know the slope, the m value, I can calculate the y-intercept, the b value, by subbing into y equals mx plus b, my m value of 9 over 8, and any point on my median for x and y. I'll choose point E for my median since that one doesn't have any fractions. So point E, the y value is -1. My slope is 9 over 8. And my x value is -2. My only unknown here is b. I can solve for b. I'm actually going to reduce -2 over 8 to -1 over 4. So I have 9 over 4 times -1, that's -9 over 4. When I bring that to the other side, it becomes +9 over 4. And I'm going to want to add it to -1, so I'm going to rewrite -1 with the denominator of 4 by writing it as -4 over 4. So that gives me a b value of 5 over 4. So I can now write the equation of the line that the median falls on, and that equation would be y equals 9 over 8x plus 5 over 4. Let's now do the right bisector of DF. The right bisector of DF I know will pass through the midpoint of DF, which we've already calculated as the point 2, 3.5, so I'm going to label that. And I know it's going to intersect DF at a 90-degree angle. So I'll just record that here as well. Mid DF is 2, 7 over 2, or as a decimal, 2, 3.5. And I know it's going to intersect DF at a 90-degree angle. So I'm going to need to know the slope of DF and then use its negative reciprocal as the slope of my right bisector. So let's find the slope of DF by using my slope formula, y2 minus y1 over x2 minus x1. So I will do 2 minus 5 over 5 minus -1, which gives me -3 over 6, which reduces to -1 over 2. If that's the slope of DF, I know my right bisector is perpendicular to that, so the slope of my right bisector is going to be the negative reciprocal of -1 over 2. So I need to change its sign, so it's going to become positive, and use the reciprocal, which means flip it. So instead of -1 over 2, it's going to be positive 2 over 1, which I can just write as positive 2. Now that I know the slope, all I need to be able to write the equation is the y-intercept, the b value. So into y equals mx plus b, I know the slope is 2, and then for x and y, I sub in the x and y coordinates of any point on my right bisector. The only point that I know is on my right bisector is the point 2, 3.5. So I'll plug in 3.5 for y. I'll write it as a fraction, 7 over 2, and 2 for x. Now I can solve for b. So I've got 7 over 2 equals 2 times 2 is 4 plus b. So I'll move that 4 to the other side. So it'll be minus 4. I'm going to want to collect it with 7 over 2. So it's going to need to have a common denominator. So right now it's a 4 over 1. I'll have to multiply top and bottom by 2. And that will give me 8 over 2, which is equivalent to 4. So I have 7 over 2 minus 8 over 2. That gives me a b value of -1 over 2. So my equation of my right bisector is going to be y equals 2x minus a half. Let me actually draw that right bisector. So I know it goes through this midpoint here, this point 2, 3.5. From there, I can use the slope of 2, which we can think of as 2 over 1, to go up to right 1, or down to left 1. I'll plot another point just so we can see, so down 1, 2, left 1. That's going to cross the y-axis where we said it would. It's going to cross at -0.5. And let me connect these points. And I'll put arrows on the ends of this line to show it's a continuous line. There's my right bisector. Notice it goes through the midpoint of DF and it intersects it at a 90-degree angle. Last part of the lesson, we'll find the altitude from vertex E. I know an altitude is going to go from the vertex of a triangle to the opposite side at a point where it's going to make a 90-degree angle with the opposite side. So it's not going to go to the midpoint. It's going to go somewhere else so that when it connects, it forms a 90 degree. It looks like it's going to be around here. So the fact that I know that it's going to be perpendicular to DF tells me that I'll be able to find the slope of it by using the negative reciprocal of the slope of DF. And if you remember from the last question, we know the slope of DF is -1/2. That tells me the slope of my altitude is going to be the negative reciprocal of that. So it's going to be +2/1, which I'll write as +2. So I know from E, it's going to go up to right 1, up to right 1, and so on until it connects to the opposite side. So this is what the altitude is going to look like. Based on how I drew it, it looks like the y-intercept is going to be 3, or at least about 3. Let's do some calculating to make sure. To find the y-intercept, into y equals mx plus b, we will sub in our slope of 2, and any point on our altitude, I'll use point E, that's on our altitude, that's where it started, as my x and y coordinate. So the y coordinate is -1, the x coordinate is -2. I can now solve for b. 2 times -2 is -4. Take that -4, add it to the other side, and my b value is 3. So the equation of the altitude would be y equals 2x plus 3. Now the altitude is contained within the triangle, but it falls along that line, y equals 2x plus 3. That's it for that lesson. Make sure you go to jensenmath.ca to find a set of practice problems to see if you're able to calculate these on your own.